Assalamualaikum warahmatullahi wabarakatuh. So for this video, our group will explaining about experiment G4 part 2, which is Schmidt Rebound Hardness Test from subject SEAA 2012. And lecturers for this experiment is Dr. Afikah binti Rahim. Before we start explaining the videos, I'm going to introduce all of our group members from group 4. The first one is Amira Dalila binti Jamaluddin, which is me. Second, Chu Zingyi. Third, Muhammad Nazri bin Muhammad Nasir. Fourth, Nasrul Nazwan bin Muhammad. And lastly, Tong Ren Hao. So for my part for this experiment, I'm going to read about the introductions of this experiment. So the Schmidt Rebound Hammer Test is a non-destructive testing method that provides a convenient and quick indications of the material's compressive strength. The rebound hammer is made up of a spring-controlled mass that slides on a plunger inside a tubular housing. Figure 1 depicts the operations of a rebound hammer. When the plunger of a rebound hammer is pressed against the surface of the tested material, a spring-controlled mass with constant energy strikes the surface and bounces back. The extent of rebound, which is a measure of surface hardness, is measured on a graduated scale. This measured value is known as the rebound number or rebound index. The rebound index is possibly the most commonly used index in rock mechanics practice for estimating the uniaxial compressive strength (UCS) and the modulus of elasticity of intact rock in both laboratories and in situ conditions. So this is the figure 1 that showing the operations of the rebound hammer.
Alright, so hi to Dr. Africa again. I'm choosing it from group number 4. And now the objective of G4-2 is to determine the uniaxial compressive strength of a rock sample, and to determine the rebound index of a rock sample, and also to determine the indicative rock type of the rock sample. And now I am going to discuss about the theory of these experiments, where a constant amount of stored spring energy is imparted through a hammer mass to a plunger, causing the mass to rebound a distance proportional to the total energy absorbed by the impact surface. The rebound index is shown by the indicator and is defined as the rebound index. And the degree of rebound varies, as they depends upon the rock elastic properties. And the height of the rebound of the mass is measured on the scale, and it is taken as the measure of the hardness. Thank you.
So for the apparatus, we use water bottle with 500 ml as a Schmidt rebound hammer. Number 2, mortar as our rod of sample, and floor as a flat surface. The procedure: number 1, water bottle was held firmly so the plunger is perpendicular to the rod of sample of rock. Number 2, the bottle was pushed slowly towards the sample of the rock until the bottle impacted. Number 3, the rebound number on the scale was recorded. Number 4, 9 readings were recorded and the average was calculated.
First, the rebound hammer must be tested. Next, make sure the hammer is perpendicular to the rock of sample and push it down slowly until the hammer is impacted. The number of rebound is recorded.
Next, we have the data analysis of rebound value and uniaxial compressive strength UCS in each of sample reading. And then we calculate the average rebound values and average UCS. And here we have the result of average rebound values, which is 37.78, and average UCS is 85.67. Next, we move on to the discussion. Based on the experiment, the higher the rebound value, the higher the uniaxial compressive strength UCS, the harder the rock. The sample used is granular diorite with a unit weight of 27 kN meter cube. Based on figure 2, the average UCS value is 85.67 MPa, and based on table 5, the sample can be considered a strong rock since its compressive strength falls between 50 to 100 Nm². There are several precautions that should be taken care of. First, The steel ball needs to be placed on a flat and level surface before the rock specimen is clamped onto it to prevent vibration and movement of the specimen during the test. Second, the surface of the specimen must be smooth and free of dust to increase accuracy. And lastly, the Schmidt hammer must be perpendicular to the surface of the specimen and held it using both hands before triggering the impact.
Good morning, doctor. My name is Tongan Hao, and I'll be talking about the conclusion. So, in conclusion, the granodiorite sample has an average rebound value of 37.78 and also an average USC value of 87.67 megapascal. The granodiorite sample, which has a unit weight of 27 kilonewton per meter cube, is classified as a strong rock because it falls in the range of 50 to 100 compressive strength according to the figure. That's all from me. Thank you.